When it comes to data security, encryption plays a very critical role. And that's why every one of us should know about encryption. Let's focus on basics of encryption. Just to give you an idea that encryption is not very new, what you are seeing right now is called CITL. This was used by Greek generals to exchange messages between units about what to attack or how to defend, and those type of secret communication used to happen using this encrypted messages. There is a message which is on the leather strip, and then there is a key, a wooden piece which has specific angles to it. So when the wooden piece matches, or when the leather is put on the similar type of wooden piece, then only the information can be decoded. Very primitive way of doing encryption, but it was still effective in that case. Now let's focus on how encryption works in real life, and I have to explain you some basic concepts associated with it. So let's talk about an analogy to understand encryption. We all use bank cards, credit, debit, whatever, and those cards have a PIN number associated with it. Probably most of us have multiple cards, and remembering multiple PIN numbers can be complicated. The easiest thing would be if I could go ahead and write down that number on the card, then it would be much easier for me to get started. But this is most convenient, but this is not at all a secure way, because if somebody finds my card now, they can misuse it for anything they want. So we want to keep convenience of having PIN readily available, but we don't want to keep it in unsecure format. So let's see one setting we could do. So let's say this is my PIN number 4582, and I go ahead and use a key with it, a number, just a very basic math we are doing here. On the first digit we would do +1, and on the next digit -1, next digit +1, next digit -1. So we have used this key, and now we apply this key on this PIN number, which is my plain text information, apply the key, and what I get now is another number which is 5491. This 5491 is obfuscation. It is not actual encryption, but to give an idea that what we did, we had some plain text information, we applied a key on top, and that key has changed the value of the data. Now I can safely store this information of 5491 on my card. Even if somebody finds the card, they won't be able to decipher the actual PIN number of my credit card. Right? Not very sophisticated, but yes, it still works. So I could use this kind of thing. So what we have here, what we have generated here from the plain text is referred as cipher text. If I have to use my card now, what I'll do, I will decrypt it. So I'll take the 5491, reverse the key. Instead of plus and minus, I would say minus and plus, -1 +1 -1 +1, and now I got the actual plain text value which I could leverage to access my account or perform bank transaction. So it is not actual encryption, but you should have got an idea that we take plain text information, we run it through a key, and then we got a cipher text which is encrypted text. Now let's understand few more concepts associated with it here. So what I have used here, I have used the key which is +1 -1. If you look here, I have used the mathematical formula like plus a value minus a value. This mathematical formula which I am using is referred as algorithm. So you may have heard about different encryption algorithms available like SHA and then Diffie-Hellman. All those type of algorithms are basically a mathematical formula which we are utilizing here. Plus and minus is a very simple one. That mathematical formula which is used in real life is more complicated than plus and minuses. Now, if I have multiple cards, just giving an example, if I use the same process of +1 -1, then again I am creating a bigger blast radius. If somebody is able to decipher this, so not my card number 1 or 2 or 3 or 4 are at risk, all my cards are at risk because this was the same key I have used. So most probably we won't be using the same key, and what we will do, we would keep the same algorithm, but we can change the value here so that my output will come again next. Let's say I say, okay, I would use every card's second last digit as the value just to randomize. So this card ends up with 5432. So instead of +1 and -1, I would say I would use the algorithm plus and minus, but the value I would use would be 3 and 3. You get my point? Now, Another card ends up with 1, 2, 3, 1, 2, 4, 1. This case, I would use +4 and -4 as a value. So this is how I am ensuring that I am not using the same key for everything. Method is same, value is same, but algorithm I am using is different. Sorry, algorithm is same, but the value is different. Value here it was 1, and this value is what we refer as a key material. So whenever we create a key, we select what type of algorithms we need, and then we provided some randomness, some key material, so that the output which is generated is a unique combination which is purely for the purpose we have selected. So that is what referred as encryption. Then you could divide encryption into symmetric and asymmetric. So we'll talk about that into the next section. Thank you.